Hey everybody, hope you're doing well. Welcome to week 8 of Algebra 2 for the fourth marking period. This is the second to last lesson you are going to have to work through for the entire year. You'll notice this is lesson 10.1, which is going to talk about something called the fundamental counting principle. This is something you learned about in Algebra 1 that we're going to touch back over and look at in a couple of different ways here. This unit 10 we would have spent more time on had we had time during the school year, but obviously with the year running short, we're going to go through a couple of sections here to cover some concepts related to probability and statistics. So we're going to look at some counting principles here in this video and the next. So as a quick reminder here, fundamental counting principle, basically this is the concept where if you have different groups of things and you have to choose something from each group, if you want to figure out how many different possibilities you can have by mixing and matching from the different groups, you multiply your options together. That's kind of what the words at the top are saying. So you can have 2 groups, 3 groups, 10 groups of things where you have to pull something from each. If you're looking for the amount of possible ways that you can get all those different groupings, you're going to multiply the options. So we're going to look here at 8 total questions. So I have 3 slides here in the video. We're going to look through some different problems here. Again, you'll see that the math to it's not very complicated. It's just more of a matter of making sure that you pull the correct numbers and multiply the correct things together. So let's go ahead and work through these. First example here, Applebee's has a promotion called the Ultimate Trio, in which you can choose 3 appetizers from the menu of 8 appetizer options. If you cannot select the same appetizer more than once, how many different Ultimate Trios can you choose? So ultimately, this question is saying, hey, you've got 8 things you can order. You have to order 3 of them to do this ultimate trio. You're not allowed to repeat your options, so you can't get 3 orders of mozzarella sticks or fried pickles or whatever you want. You got to get something different with each appetizer. So the way I'm going to set this up, now again, you don't have to set it up exactly how I'm doing it, but for the sake of organization, I'm going to set up these little bins. So I know I want to order 3 appetizers. So here's appetizer 1, appetizer 2, appetizer 3. Now again, this fundamental counting principle means we're going to multiply our numbers together. So when it comes to ordering appetizer number 1, well, I had 8 things to choose from the menu. So that means first appetizer, I got 8 options. Now, when I want to pick the second appetizer, again, I'm not allowed to repeat, so I'm down an option. That means I only have 7 things to choose from for appetizer number 2. Third appetizer, same deal. I'm not allowed to repeat, so now I'm down to only 6 options. So to figure this out, all I would need to do is multiply 8 times 7 times 6. And when I do that, I have 336 possible ways that I can select an ultimate trio. The next problem here is pretty similar in concept. So we have 50 people entering a contest in which 5 prizes will be awarded. If each prize is awarded to a different person, how many ways can the 5 prizes be awarded? So again, nothing's repeating in this case. So kind of similar to the last question. So if different people are getting prizes, then same person can't get 2 different prizes in a row. So we have 5 prizes. So I'm going to set this up again. Prize 1, prize 2, prize 3, prize 4, and prize 5. So these are my 5 prizes. Now, basically, how many people can win it? So if I have first prize, there are 50 people in the contest. So 50 different people could possibly win the first prize. Now, again, different people are going to win these prizes. So for the second prize, I'd have 49 people have a shot at it. Third prize, 48. Fourth prize, 47. And fifth prize, 46. So I'd multiply all these numbers together. The one thing about fundamental counting principle is sometimes you tend to get some really big answers. It doesn't necessarily mean you did it wrong. It just, again, when you multiply stuff, you get big responses. For these, to figure out the amount of possibilities that 5 prizes can be awarded to 50 people, there are a total of 254,251,200 ways that these 5 prizes can be awarded. This third problem here, you are reorganizing your bookshelf. Okay, you can fit 10 books on the shelf. How many ways can you organize the books? So we're going to assume again all 10 books are different books for whatever reason. All right. So this case here, now again, you can set up the bins, but since I'm not limiting how many things you're going to organize, okay, 10 books on the shelf, I need to organize them all. Let's just think through this logically. First book I put on the shelf, I have 10 things I can put first. Then I have 9 things I can put second, 8 things to put third, 7 things to put fourth, 6 things to put fifth, 5 things to put sixth, 4 things to put seventh, 3 things to put eighth, 2 things to put ninth, and 1 book to put last. So again, if you want to put the little bins here, so again, this would be the first book, second, third, fourth, and then so on and so forth. And I'm going the whole way this time because, again, I'm not limiting and saying, hey, we're only going to organize the first, 3 books. We're organizing all 10 of them. So 10, 9, 8, 7, 6, all the way down to 1. Do not include 0 in this because, obviously, when you multiply by 0, it's going to wipe the whole thing out. Okay? You only go down till you have that last book in the last spot. So if I try to organize 10 books, I have 3,628,800 different ways I can organize them. Okay. So again, these numbers probably seem like astronomically huge, but again, when it comes to organizing and sorting things, even with a small sample size like 10 books, it's amazing how many different ways you can actually organize stuff. So, for whatever that's worth, there you go. Let's go ahead and take a look here at the 4th example. All right, so this example here, this is kind of true in terms of when I used to, go into work and have to, dress up in a collared shirt and some dress pants here. Trying to select a work outfit for the day. You can see I can choose from the following colors of polos, and this is a limited list of colors just so that this problem didn't have 400 words to it. So I can choose from red, orange, yellow, green, blue, black, pink, purple, maroon, charcoal, aqua, and coral. Those are some fancy colors at the end. I can also choose from the following designs of polos: striped, geometric, or no design. He also needs to wear khakis, black dress slacks, or blue jeans. How many different outfits can Mr. Aiello choose from? So, since I'm a man of high fashion, I've got a lot of different ways that I can organize my outfits for work. So, ultimately though, a lot of words in this problem, but we can whittle this down a little bit. So, I essentially have 3 categories of things to choose from. I have the color of my shirt, I have the design of my shirt, and I have the type of pants I need to wear. So, if you count carefully here, let's see, with all the different colors, it looks like I have 12 different colors to choose from. 3 different design options. I know one of them, it says no design, but that is technically an option where it would just be, the flat color, nothing on it. And I have 3 different types of pants. So all I would do here is multiply 12 times 3 times 3. So that would give me 108 different outfits I could wear, just based off of those parameters. Number 5 is a very similar problem to number 4, because again, you're kind of given all the categories pretty nicely laid out here. So choosing your lunch from the cafeteria, you've got 5 choices of fruit, 8 choices of vegetable, 4 choices of a main entree, 6 choices of drink, and 3 choices for dessert. If you have to choose one item from each category, how many different lunches can you choose? So again, I put that qualifier in because, again, devil's advocate of, well, I'm not going to get, something as a vegetable or whatever the case may be. We're going to assume, again, you're taking one of everything, no more, no less. So this type of problem is actually probably the easiest to do because I outright give you how many are in each category. So we don't have to think really too much. So again, your different things to choose from. You've got your fruit, you got your veggie, you got the main entree, you've got the drink, and you've got the dessert. Now, in this problem here, just because of the simplicity of it, again, you can set up the bins if you want, but ultimately, yeah, I've got 5 choices of fruit, 8 veggie choices, 4 entrees, 6 drinks, 3 desserts. All I'm going to do is, in this case, just multiply all of those numbers together. I have 2,880 ways that I can select my lunch. Let's take a look here at number 6. So here you're given 5 multiple choice questions on the test. If each question has 4 possible answers, then you answer each question. how many different ways can you answer the questions? So we're kind of assuming here, again, you're just taking blind guesses. Obviously, if you're taking a multiple choice test, hopefully you would know some of the answers here, but this is just asking for, again, assuming you answer each question, kind of if you're just taking a blind guess, how many different ways could you answer these? So you have 5 questions. So question 1, question 2, question 3, question 4, and question 5. Now, here's the thing. Each of these questions has 4 answers. So, since they're each separate questions, question 1, you got 4 things you can pick from. Question 2, you got 4 things to pick from because it's a new question. Same with question 3, 4, and 5. So, the number stays the same in this case because, again, 5 questions, okay, they're each going to have their own set of answers. So, you'd have to pick one from each. You don't lose an answer as you go through it. So, that's why we're using the 4 5 times. So you multiply 4 times 4 times 4 times 4 times 4. If you're just taking blind guesses, you have 1,024 ways that you can answer these 5 questions. These last couple here, we're going to talk about some things with some digits and letters, just because these are common questions that you see. And actually, this is a pretty easy and common use of using fundamental accounting principle and some of the other counting concepts that exist, because ultimately this is why passwords have so many different variants to it. If you notice, when you use a password, you have to do a whole bunch of things where you need at least 8 characters, but they all can't be letters, they can't all be numbers. You need to have a special character, you need to mix between upper and lower case. The more things you throw in, the more possible ways that you can create passwords. It makes it harder for anybody to hack anything. It's a lot better than just using letters or just using numbers or some basic combination of that. But to keep everything easy to calculate, we're going to go with some easier combinations of things here. So let's go ahead and take a look at number 7. This is why I also use the phrase, a passcode on an old computer requires 6 characters, 4 digits, 2 letters. Here's something very important that we need to make sure we establish. Digits, that means 0 through 9. What that means is, if I say digits, that means there are 10 digits, okay? 10 is not a digit, but 0 is, okay? So if I talk about digits, that means you have 10 things. Letters, you may know your ABCs, but you need to know that there are 26 of them. Okay, these are always common things I've ran across in Algebra 1 that some people tend to forget about. We're just going to make sure here, as we're at the end of the year, that we remember these 2 basic facts. So, using that to answer these 2 questions here underneath. If the characters can repeat, how many different passcodes can be created? So, you have 6 characters. 4 have to be digits, 2 have to be letters. So, the first 4, we have to have 4 digits here, so digit 1, digit 2, digit 3, and digit 4. We need 2 letters, letter 1, letter 2. Now, since the characters can repeat, I would have 10 options for digit 1, anything from 0 through 9. Since I'm allowed to repeat, that means I would have 10 options for each of my digits. I don't have to knock anything out. I can use 0 4 times, I can use 9 4 times, it doesn't matter. I have 10 options for each. Same with the letters. I have 26 options for the first letter. I then also have 26 options for the second letter because, again, it doesn't matter. It says things can repeat, so we don't have to worry about knocking anything out. So I multiply all that together, and you end up with 6,760,000 different passcodes. Now, let's vary that up a little bit. Let's say the characters cannot repeat. So we're going to still have the same setup where, okay, we have 4 digits, 2 letters. Those are the characters that need to be in our passcode. But if things are not allowed to repeat, that means we're going to have to change how many things we can pull from. So I'd still have 10 options for my first digit, anything 0 through 9. But once I pick one, since I can't repeat, I'm down to 9 options. Then 8, then 7 for my total of 4 digits there. With letters, I have 26 letters for the first option, but again, I can't use that same letter twice, so then I'd be down to 25 letters for the second option. So our numbers are going to change drastically here because we're not allowed to repeat anything. So when we do that, if I take out the fact that I'm not allowed to repeat, I cut the available amount of passwords here in a little bit more than half. 3,276,000 passwords can be created if I'm not allowed to repeat things. So there is some benefit to repeating things. Obviously, it's just a matter of when you make your passcode, not having everything being the same digit or the same letter. All right, last problem here. Number 8. Local telephone number has 7 digits. Bum, 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 bum. Fun fact about local telephone numbers, they cannot start with 0 or 1. How many different telephone numbers can be created? So, again, we're kind of ignoring area code here, but obviously you might see a question with something similar to that. Again, it's the same idea. But again, we have 7 digits. So digit 1, digit 2, digit 3, digit 4, digit 5, digit 6, and digit 7. Now, we know in phone numbers, numbers can repeat. So that's not much of an issue. But there is one little caveat to this. It cannot start with a 0 or a 1. So what that means is my first digit has to be 2, 3, 4, 5, 6, 7, 8, 9. I have 8 possible options for my first digit, not 10. I can't use all the digits as a possibility because I'm not allowed to use 0 or 1. That leaves me with 8 potential options for the first digit. However, I don't have anything else as a qualifier or anything else saying I can't use for any of my other digits. So I have 10 possible options for each of the other digits. So you do want to be careful of problems that say, hey, you can't start with these things or end with these things, because again, that can change your numbers just a little bit. But ultimately, again, I can use all 10 digits for each of my options, except for the first one. Since I can't use 0 or 1, I'm going to use only 8 options. Ultimately, if this is my case, that means I can create 8 million different phone numbers. Now, you notice there's probably more than 8 million people in the world that have phones. Okay, this is why area codes are super important, because it adds another 3 layers of digits to it, which also adds a lot more possibilities and a lot more different phone numbers that can exist. So that's how we use the fundamental counting principle. Again, a lot of multiplication is just a matter of reading the question carefully and using the correct numbers. So your assignment for this, it's a Schoology quiz, 8 questions. Make sure, again, you take the time, read them carefully, because, again, your answers are either going to be right or wrong on those, because I'm not really looking for work. I'm just going to look for the answer for those questions. But, again, they'll be very similar to these, so refer back to this if you need to. If you have any questions, please feel free, as always, send me a message on Schoology, shoot me an email, stop by my office hours on Zoom. I'll be more than happy to help you. Otherwise, again, this is the second to last lesson. Make sure you are up to date on your work. If you owe me anything, if you are caught up, awesome. You're almost done. Keep pushing forward. So otherwise, if you need anything, let me know. If not, thanks for watching. Stay safe, stay healthy, and we'll see you next time.